Python is considered one of the world's most popular programming languages and a great place for beginners to learn how to code. However, many online courses can be dense, filled with jargon, and not meant for true beginners. Hi, I'm Nick Walter. I've been a developer for over 10 years and have been teaching students to code for over 7. I'm a self-taught programmer, so I know what it feels like to be a true beginner. In my course, Python for Non-Programmers, you'll be learning Python from square one in a relaxed and fun environment. We'll learn Python step by step with short 5-minute videos explaining a topic and then giving you a quick challenge to make sure you've truly grasped what we just learned. We also apply our learning in this course by creating 3 complete projects: a digital fortune cookie, a word counter, and a number guessing game. So, if you're ready to learn the world's most popular programming language in a fun and beginner-friendly way, join me in Python for Non-Programmers. Let's get going! Hi, and welcome to Python for Non-Programmers. If you're starting from square one, you're in the right place. Now, the great thing about learning Python, which is the most popular programming language in the world, is that you can run it almost anywhere on Windows computers, Mac computers, Linux, and even on the internet in your browser. And for this course, to help us dive in and learn as quickly as possible, we're going to be typing and learning our Python code in the browser. So I'm going to be using the website replit.com, and I'd encourage you to use the same website as me. However, if you'd like to use your own setup, you can go Google Python online, and you'll see lots of different websites that offer the same service of being able to run and test and see Python code in your browser. So if you're going to follow along with me and use replit.com, go ahead and create an account and hit the sign up button and join me on the other side. All right, now that you have created an account here in REPL, we need to create a new REPL, which is essentially a new file to test out our Python code. So the website will likely change over time, but you can see over here on the left, I have create REPL, and also in the top right, we have a plus button to create a new REPL. So however you need to create a new REPL, then we need to select Python as our programming language, and then give a title to our REPL. Again, we should have a new REPL for each different video in this course, for each concept that we're learning. So let's go ahead and name this video First Line of Code. Okay? Hit the Create REPL button, and in a second here, REPL will get our environment set up for us. Again, this is the place we'll be able to type out and see the results of our Python code. So here, where we have main.py, this is our Python file. Python files have the .py extension. Let's go ahead and type our very first line of Python code. So I'm going to type in all lowercase, print, and then do an open and close parentheses. You'll notice by just doing the opening one, REPL is smart enough to create the ending one. It's a nice little thing for us there. Then we're going to add some double quotes and then type inside of here, hello world. It's typical when learning a new programming language to get the term hello world to display for your very first thing that you do in the language, just to make sure that you have the beginnings working. So once we have that there, we're going to hit this run button up top, and we should see over here on this black box over here, which is called the console, the term hello world. And if we type something over here, like hello Nick, we should also see that go in the black box once we hit the run button. So I hit the run button, we now see hello Nick. Awesome! You have your very first line of Python code. Give yourself a pat on the back. Now, a few housekeeping tips here. With REPL, if you want to change the font or the color of things inside of your browser, you can come over here to the settings icon and change things like the font size, and you can also change the color and how things look. So if you want to customize anything, this is the place to do it. So with that in place, let's go ahead and move on to learning our very first concepts in Python. Now that we've written our very first line of Python code and we have our environment all set up here, it's time to learn the absolute fundamental building block of Python, and that is variables. So because we're learning a new concept, we should create a new REPL. So let's go ahead and click on the REPL logo here to get back to the dashboard or home page. And let's now create a new REPL. So again, we need to make sure that we have Python selected. And because we're going to be learning about variables, I'm going to name this variables. Now, what are variables? Variables simply just hold a piece of information that can change over time. It's really just that simple. They can hold numbers, they can hold text, and as we get further in this course, you'll learn that they hold other types, like Booleans. So just to start out here, let's go through an example of, let's say we want to create a variable that represents how much money we have in our wallet. Now, shocker, as of recording this video, I took a look at my wallet. I have $41 in there. So not a ton, not too shabby either. But if we wanted to represent this amount of money in my wallet, we would do that in Python by first giving a name to our variable, which I'm just simply going to call wallet. Okay, this is now the name of our variable. Now, I said that variables hold a piece of information. How do we put some information into this new variable called wallet? Well, we have the name, and then we hit space, do an equal sign, another space, and then put in some sort of value. So for me, because I have $41, I'm going to say wallet is equal to 41. Essentially what's happening here is we're taking the value of 41 and putting it into the variable called wallet. And now that we have this code, you're saying, great, let's go ahead and run this and see what it looks like. So hit this run button here, and you'll notice on the console, nothing shows up. And the reason for this is that in Python, even if you create a variable and put some information in it, you will not see any of that information on the console until you print to the console. Now, I know the word print typically means that you're going to put some ink on some paper, but in the programming world, and specifically with Python, whenever you print something, you're just getting some information to show up on the console. So let's go ahead and create a few new lines after the term where we create wallet and set it equal to 41. Let's type all lowercase print, just like we did last video, and put some open and close parentheses. But now, instead of putting the words like hello world or hello Nick inside of there, let's put the word wallet, that variable that we just created. So I'm going to say print with parentheses wallet. And now let's go ahead and hit the run button and see what we get. And now you can see that the number 41 appears. So if we ever want to check what a variable is holding, what piece of information it is, be it numbers, text, whatever, we have to print out that information to the console. So now that we have this down, I'd like to share a tip with Python. You'll notice that I put a blank space between line 1 and 3, where first we created the variable and then we printed out the information inside of the variable. Why did I do that? For me, just stylistically, I like to have a little space. And in Python, you can have as many or as little spaces in between your lines of code. This will still run completely fine, as well as this. They're all the same. So if you just like to have space in your code, you can use as much or as little as you'd like. Now, one more thing with variables is that the value that they're holding can change over time. So let's say with our wallet, I went and bought some pizza, and so now my wallet only has, let's say, $32 inside of it. I can update the value of the variable. I can say wallet is now equal to 32. Previously, it was equal to 41, but because I've spent some money, I now only have 32. And if we want to see what the value of this is, again, we're going to have to do a print to see the new value of wallet. So let's go ahead and hit the run button. And you'll notice in the console, when we first printed, wallet was equal to 41, and now it's equal to 32. So variables hold a piece of information and they can change over time. Now, to really cement this concept and make sure that you've got a good grasp on it, I'm going to introduce a challenge. And for the rest of this course, after we learn a concept, I'm going to have a little challenge for you. And I really want you, whenever I present you a challenge and I tell you to pause the video and try it out on your own. It's really going to help your learning and make sure that you're understanding what I'm saying and you're not just listening and following exactly what I'm doing. So the challenge that I have for you is I want you to make a variable called day and set it equal to the date of the month. So whether it's the 13th, the 15th, the 4th, whatever, make that variable day and set it equal to the date of the month. So hit pause and go do that on your own now. Okay, hopefully that went well for you. For me, at the time of recording, day is equal to the 21st. So I said day is equal to 21. Now that you know what variables are, we're going to start learning about types. And what are types? Types in Python are just the different type of things that we can put inside of a variable. So for example, in this video, we're going to be learning about ints and floats, which are two number types. So let's start first with ints. Ints is just short for integer. It means a whole number, a number that doesn't have any decimal places connected with it. So for example, in the challenge from the last video, I had said day is equal to 21. This is an example of an integer, right? It's a number that doesn't have any decimal places. So we have this variable day, it's set equal to the integer or int of 21. Now, integers can be positive or they can be negative. Let's say it's a really cold day outside and the temperature is negative 15 degrees. We can say temp is equal to not just 15, but also negative 15 degrees. So again, whether it's positive or negative, as long as it doesn't have decimals, it is an integer. And this brings us to our next type, which is floats. Floats are numbers that do have a decimal place connected with them. So for example, when I'm tracking my weight, I like to be very specific. I like to go down to the decimal on it. So for example, I might record my weight as equal to 190.4. For me, that 0.4 is very important. I want this specific number, and this is an example of a float. It has a number with a decimal on it. And it doesn't just have to be one number after the decimal, like we could get really specific here. And with floats, they can also be positive or negative. Just like integers, they go on each side. So with these two types, what can we do with them? Well, a really cool thing that we can do with Python is some math. So anytime we want to do some type of calculation, we can do addition, subtraction, multiplication, division, and we can use these different variables that we have. So let's go ahead and on a new line, let's print out and just do some math without variables, and then we'll do them with some variables. So for example, I want to know what 3 plus 6 is. I can simply just type that inside of my print line here, and if I go ahead and hit the run button, in our console we'll see 3 plus 6 is 9. Okay, that's cool. What if we want to see what day is today 3 days from now? We can say day plus 3. This will give us the date in 3 days. So if I go ahead and run this, you can see that day was equal to 21. Then we added 3 on top of it, and now we're displaying the number 24. The 24th is 3 days from the 21st. Some other things that we can do if you want to do some multiplication. If I want to see what my weight is doubled, I can type weight times, and to represent multiplication in Python, you use a star symbol or an asterisk, and then the number 2. So I'm going to take my weight and times it by 2, and there we can see it's 380.8. Some of the other types of math that we can do are division. For division, we just do a /. So let's see my weight divided by 2, that is 95 pounds. And we can also do subtraction with the minus sign. Okay, so those are the basic types of math that you can use in Python, and you can see how we can work with variables that again are holding these different types and using them to do some great math. So it's time now to make sure that you've got a good grasp on what we learned here. Let's do a challenge. I want you to find something around you in your life to represent an int and also a float and put them inside of variables. So for me, I like weighing myself down to the decimal. Find something around you in your life that you can count using a decimal, and also something with an integer. Okay? Hit pause, do that now. All right, hopefully that went well for you. For me, I'm going to represent my age as a whole number. I'm going to say that my age is just 32. Then I really like cryptocurrency, I'm going to say that I went and bought some Bitcoin. I got 0.00435 Bitcoin. Okay, you can see this is a float because we've got a very specific decimal here. Now that we've learned about two different number types, integers and floats, we're going to learn about a new type called strings. And strings are a way to represent text inside of Python. So I left some examples here to show both an integer and a float, and let's talk about our new type, which is string. So let's make a string variable that represents my shirt color. So I'm going to make a variable here called shirt, and I'm going to set this equal to a color. So my shirt is blue, so I'm going to say shirt is equal to blue. But you'll notice if I try and run our code here, I'm going to get a really nasty looking error that just says, hey, this thing blue, it's not defined. And the problem is here that in Python, whenever you want to represent a string or represent text, you have to put that text with some quotes around it. So for example, I'm just going to put some double quotes around the term blue here. And now that I've done this, when I hit the run button, you'll notice everything's working. We don't see anything outputted to the console, but we also don't see any errors. And the reason we don't see anything in the console is because we haven't printed anything. If we want to do that, we'll say print and put shirt inside of the parentheses, and now we'll see the term blue show up. And you'll notice the term blue there, it doesn't have those double quotes. Again, the quotes signify that what is inside of them is a string. It's the piece of text that we want to put inside of a variable. Now, something cool about Python is you can use double quotes or single quotes to represent a string. So for example, if I do single quotes here instead of double and I run our code, we're going to have the exact same output. The only thing that we can't do is have a mix. We can't start with a double quote and then end with a single quote. We have to be consistent about how we represent our strings. So connected with this, let's say that we want to have a new type of variable. Let's say it's the tag name for a new store that we have. So I'm going to say store is equal to, and the string that I want to represent is something like Nick's Pizza Shop. Okay, so if I were to go and put single quotes around this, you'll notice that we have an issue. Inside of my string, I make use of a single quote when I say Nick's Pizza Shop. And if I try and run this again, I'm going to get an error. And I don't even have to run here in REPL to see that I'll have an issue. Whenever you see this red squiggly line, this gives you a good idea that you have a problem and that you need to fix it. So how could we fix this situation? Well, in this case, I can just change my outer quotes to double quotes instead of single. And because I don't use a double quote inside of my string, now this is completely valid and I can run this and not have any errors. So if we want to make this a little bit more complicated, what if we had a string like Nick's Pizza Shop, comma, the best there is? And I'm going to put best in quotes because best is kind of relative. And you'll notice now that we run into an issue. This string not only has a single quote after Nick's, but also has double quotes around best. So if we try and put our single quotes around the whole thing, we'll run into an issue because we use a single quote inside of that string, and the same thing with the double quotes. So how can we handle this situation? Well, in a string, if any time you want to have a quote but don't have it actually represent the end of a string, you can put a backslash in front of it. So for example, where I have this single quote here, I can put a backslash in front of it, and that's a way to say, hey, don't treat this as the end of the string. Have this just be a regular single quote. And you'll notice doing this fixes our situation. So if we go ahead and print out whatever we have inside of store here, we'll see that we get a nice looking string that says Nick's Pizza Shop, the best there is. So there you have it. You now have three different types in your tool belt. We've got integers, floats, and strings. To make sure you got a good grasp on strings, let's go ahead and do a little challenge here. I want you to put the name of a movie you like into a variable called movie. Again, don't forget your quotes there. Hit pause, do that now. Okay, hopefully that went well for you. So we're going to have a variable called movie, and I really like the movie The Sandlot, so I'll say Sandlot with the single quotes around it. Again, you could have double, up to you. In this video, we're going to be learning about how we can take variables and place them inside of our strings. So I've gotten a few variables set up so that we can practice this. I have the day, the month, and the temperature. And notice the month is a string variable, what we just learned in our last video. So let's say I want to print out a string about today and what the temperature is. I'm going to say print with some parentheses and put a double quote inside of there so that I can create a string. And I'm going to say something like, today is October 21st, and it's 65 degrees outside. Okay, so with this information, if I go ahead and run our code, you can see that string that we created, today is October 21st, and it's 65 degrees outside, is displayed. That's great. But let's say we wanted the string to actually represent the different pieces of information we had inside of our variables. So if the day changed to the 25th and we run our code, it still says October 21st. It will always say October 21st. What if we change the temperature to something really cold like -15? It's still going to display 65 degrees outside. So the question is, how do we make it so that this string that we are printing represents the values that we have inside of those variables? Well, what we can do is use something called an F string. So in Python, at the beginning of your string, right before your first double or single quote, you're going to just put a lowercase letter f, just like this. So even before we do anything else, I want you to see here that if we run our code, everything still works. I know it seems strange. You just put the letter F and it's still valid. Yes, it is, because when you have that F, it means that now you can place variables inside of your string. So for example, where we have the date, where it currently says 21, I'm going to delete this and put in some curly brackets. And inside of those curly brackets, I'm going to put the variable day. So now that I have that there, I'm going to run our code. And look what we get outputted in the console. Today is October 25th, and it's 65 degrees outside. So it followed whatever day was. If I change day to the 3rd and I hit run here, now it says today is October 3rd. How cool is that? So let's keep this going. Let's say instead of October, we're going to replace this with curly brackets, and we're going to put the month variable in there. And the same thing with the degrees. Instead of 65, we're going to replace that and say that this should be the temp. So now that we have this and we run, it now says today is October 3rd and it's -15 degrees outside. Let's change our month to September. And when we run, it says today is September 3rd and it's -15 degrees outside. Great. So what's so cool about this is we can represent all different types of variables inside of here. Not only can we represent integers, we can also represent strings. And if we had any floats, those would work as well. Now, one thing that I want you to notice about REPL here, and a lot of different code editors will have this, but it's really nice to see that, for example, strings are represented in red and numbers are represented in green. And you can see that prints are purple, the equal sign is blue, and as you code more and more, you'll notice that this will help you. If we look inside of our F string, you can see anywhere that we used variables, that was black instead of the usual red text that you see with the string. And so it's these little tiny details that will really help us as we're coding. So to make sure that you've got a good grasp on this, let's go ahead and introduce our challenge. What I would like you to do is make a variable called day name and set it to the day of the week, like Tuesday, and add it to the string that we've created above and are printing to the console. Okay? So basically, I want you to expand our example a little bit to, instead of just saying today is September 3rd, make it say today is Tuesday, September 3rd, and have that in a variable so that we can change it over time. Hit pause, do that now. All right, hopefully this went well for you. I want to take this time to mention that anytime in Python you're going to have a variable that has more than one word in it, for example, day name, it's usually not a great idea to just say, day name is equal to Tuesday. That makes it a little bit hard to read. Typically in Python, we like to put an underscore between the two words so that it's a lot easier to read. We can say, oh, this is the day name. Again, you don't have to, but it's a good practice to get used to. So with this day name, we're going to update our string here that we're printing to say today is, and we want to say something like Tuesday. But again, because we have the F string, we're going to say we want to print out whatever is inside of day name. All right, let's go ahead and test it out. Today is Tuesday, September 3rd, and it's 15 degrees outside. Excellent. We know about three types right now. We know about integers, floats, and strings. We're now going to learn a fourth type, which is called a Boolean. A Boolean is a way to represent a yes or no situation, true or false, 1 or 0. If you've ever heard the term binary, that's exactly what a float is. It's either this thing or that. So you may be thinking, that's kind of a weird type. What sort of situation would that come under? A really common one is, for example, is saying whether something is on or off. So for example, if I want to make a variable that represents whether my light is on or off, I can say light is on, and I can set this either to true or false. This is that new type, which is a Boolean. So if we want it to be true, to say yes, the light is on, we say capital true. And you'll notice we don't put any double quotes around it. It's not a number. It's its own thing here. It's either capital true or it's capital false. If I did try to put double quotes around this, this goes from a Boolean that's equal to false to a string that's equal to the word false. So it's really important that it's just the word there, capital true or capital false. So really, that's all the possibilities for a Boolean. It's either true or it's false, which is really interesting to think about because integers, it could be any amount of huge numbers. Floats can go to very specific numbers. Strings could be any combination of letters and characters, but a Boolean is either true or it is false. Those are the only two options. So you may be saying, what is the point of a Boolean? Why would we ever want this type? It just seems so useless. Well, they really show their value when they're used with something called an if statement. So an if statement takes our code and, in my opinion, really brings it to life. It's almost as if now you're in a choose your own adventure story because you can make different decisions depending on whether a Boolean is true or false. So for example, let's say if the light is on, we want to print out some information to the console that says, hey, the light's on. Okay. What we can do is use an if statement to say if space, and then we're going to type out light is on, and then we're going to do a colon. Okay. And this is saying, okay, if this light is on Boolean is equal to true, then on the next line, we want to run the following code. So I'm going to print out here, and I'm going to say something like the light is on. Okay. So I'm going to go ahead and run this, and I just want you to see this. When the Boolean light is on is equal to true, we see in the console it says the light is on. If I change this to false, look what happens when we run. We get nothing, which is so cool. Our code now is able to make some decisions. On line 8, where it says print out the light is on, that code only gets run if line 7, where it says, is light on equal to true or false? If it's equal to true, it's going to run that code. If it's equal to false, it will not run that code. So one last tidbit that I'd like to show you here is that when you have an if statement, you have if space, the name of the Boolean that you're checking, and then a colon. That next line, you'll notice, is a little bit separated. It's a couple spaces over. You can also do this if you hit a tab. It will move that over for you. But the important point is that tab is very important. Any code that's tabbed over after that if statement is going to run. So for example, I can print out lots of different things here. I'm just going to say like hello, for instance. Let's change light is on back to true. And if we run this, look, both of these lines get run. But if we set this back to false, none of these get run. And that's because they're tabbed over. You'll notice if I take this one that says hello and I bring it back to the very left so it's not tabbed over and I hit run, it's still going to run even though light is on is equal to false. It's just with an if statement, Any code that is after the if statement that's tabbed over, that will be run. If things are not tabbed over, they won't. So that's an important style thing to notice in Python. Okay, so to make sure that you got a good grasp on what Booleans are, I'd like you to find something around you that could be represented by a Boolean and make a variable to represent it. Go ahead, hit pause, do that now. Now, there's likely a lot of different digital things around you. You're probably watching this on a computer, and you could make a variable that says, is computer on or off? Again, that sort of power on, power off is a great example for using a Boolean. One that I thought of that I thought would be a little bit fun is whether my baby is sleeping or not. He's essentially either awake or asleep. Sometimes it can seem like he's in the middle of the two, but I thought this would be a fun example. So I'm going to say baby is asleep. And I'm going to set that equal to true. He's napping right now, and he is in the true Boolean situation. Let's keep learning about all the cool things that if statements can do. So right now we have an example where we have a Boolean. Light is on, it's equal to true. We use an if statement on line 3 to say if the light is on, meaning that if that variable is true, print out line 4, the light is on. So if we go ahead and run this, we can see that text showing up in the console. If this is false and we run this code, you'll notice that we get nothing in the console. And that's expected. That's what we wanted. We didn't want anything there. But how nice would it be able to say, if this thing is false, let's print to the console, the light is off. Wouldn't it be nice to be able to do that? Well, we can in Python. So let's go ahead on line 5. Let's write else, all lowercase, colon, and then on the next line, and make sure that you're tabbed over, let's print. So in this case, this means that the light is off. We're going to print out something like we're in the dark. So let's go ahead and run this and see now when light is on is equal to false, we get line 6 running. So we have printed out to the console, we're in the dark. And if we set it equal to capital true and run that, we get the light is on. Do you see how this now with this if statement, we can do things if it's true and also if it's false. We have the ability to work with either or, this or that. Isn't that excellent? And we can take this concept even one step further. So what we can do is we can take variables and compare things with them to ultimately say yes or no to a certain line of code. So let's go ahead and bring back an example we were working with earlier. I'm going to say weight is equal to 190.4. So let's say I want to make sure that my weight is under 195 pounds. Maybe, I'm doing some sort of diet thing and I want to make sure that it's below that. What I can do is I can make an if statement and use a comparison to generate a Boolean. So I can say if weight is less than, and you do this little caret sign, if the weight is less than 195 colon, and then what I can do is print out something that says you're underweight, smiley face, okay? So if we go ahead and run this code, look what happens. Because 190.4 is less than, it's below 195, I get printed to the console, you're underweight. So what we've done here is we've made a comparison. We're taking an existing variable on line 8, the weight, and on line 10, we're using it to compare and say, is this thing less than 195? And ultimately, this comparison here, this generates a Boolean. When the weight is less than 195, that makes a Boolean. For example, I could copy this chunk of code and paste it up here for if the light is on, and this is completely valid code. Well, it's not valid code because the weight has not been set up before that line, so I'd have to put weight is equal to 190.4, and then this would still work, and that's kind of a silly example, but it's all to illustrate that when we compare two things in Python, ultimately it turns into a Boolean. It turns into true or false. So as you can see here, we got the if the weight is under 195, there's all sorts of comparisons that we can do. We can say if it's less than or equal to, so that if it's 195 exactly, that's also included. We can go the other direction. We can say greater than or equal to. If we also do two equal signs, that means if weight is exactly equal to 195. If we do an exclamation point and an equal sign, that says if these two things are not the same. So you kind of see how we can use these different comparisons to really make our code come alive and do different things. So to make sure that you've got a great grasp on this, I've got a challenge for you. So what I'd like you to do is make a variable called age, and if someone is 18 years or older, print out that they're an adult. Otherwise, print out that they're a child. Okay? Go ahead, hit pause, do this now. Okay, hopefully that went well for you. So I'm going to start first by making a variable called age, and I'm going to set it equal to my age of 32. Then I'm going to start working on my if statement. So we need to say if someone is 18 years or older. So I'm going to say if age is greater than or equal to 18, colon, and then in this situation, I want to print out that they're an adult. So I'm going to say print, and inside the parentheses, I will say adult. And then I'm going to do an else, and it's really important, make sure your else is not tabbed over. I'm going to bring it back to the left by deleting those extra lines. And then the part that is tabbed over is this next print statement where I'll say this person is a child. Okay? So let's go ahead and run this to make sure it's working. So if the age is 32, it says they're an adult. If the person is 18, it still says they're an adult, but if I go down to something like 17, then it says that they are a child. Well, this is an exciting moment for us because we've just spent a section learning a bunch of different Python skills. You've kind of gotten your feet wet, and in this section, we're going to take all those skills and bring them together to build a project. In this section, we're going to be building a little fun fortune cookie project. And what's so cool is you'll get to see all these different things we learn, how they work together to make something cool. Ultimately, if you're not going to be building things, there's really not a whole point to learning Python. So I'm hoping that as we build these projects, you'll really get a good grasp for how cool and awesome Python is. So before we can start building our project, there's a really important concept that we got to learn, and that is randomness. In Python, how can we introduce some random numbers? On our fortune cookie, we're going to want to say that the lucky number of the day is this or that. And we'll also want to provide different fortunes each time someone asks for a fortune cookie. So in order to get randomness into our Python project, we're going to import a module. Now, a module is just a fancy programming term to say a chunk of code that someone else has written. So in our case, we're going to type all lowercase import space random. And what we're doing is we're importing the random module from Python. So Python has all these different modules, but you don't need them all the time. So that's why if you ever need to use, for example, some randomness in your code, you have to import it. You have to bring that module in. Now, if you want to use this random module that we've brought in, you're going to type out the name of the module, in this case, random, and then you're going to do a dot. And there's all sorts of different options that we can use with this module. So my personal favorite is the one that gives us a random integer. So if we start typing rand int, you can see Replit even helps us suggesting, say, hey, I think this is the one that you want, and you can hit enter on that autocomplete if you'd like. But with rand int, you give two parentheses, open and closing, and then you have to provide two numbers, basically your minimum and your maximum. So if I want a random number between 1 and 10, I just type 1, comma, 10. And what this will do is give me back a random number between 1 and 10. Now, if I run this, you'll notice nothing shows up. But again, this is that situation where, well, if you want something to show up on the console, you've got to print it. So let's go ahead and print out whatever this random module is going to give us. So I'm going to put print parentheses around all of that and hit run. And look, this time when we run, we get the number 8. But if we run it again, we got the maximum. We got 10. Then we got 7, 9, 4. It just picks a new number every single time. Isn't that cool? Now we can create random integers in our code and use them how we like. Another thing that we can do is not only create random integers, but we can create floats. So if we say random dot, and then we want to do in this case, we just call it dot random. and we do the open and close parentheses. Don't put anything inside of it. So random.random, and let's go ahead and print this as well. This will give us a random float between 0 and 1. So you'll notice now if we run this 0.309, run it again, 0.315, 0.394. It's always started with 0.3. Let's get something else here. 0.4, okay, 0.4 again, 0.2, 0.9. There we go. We're starting to see the whole spectrum there. But this is a way that you can introduce randomness either via an int or a float. Now, I'd just like to mention that you may be wondering, how did I know that I had to type out random.randint or random.random for the float? Well, if you just simply Google Python random, you're going to get a ton of great resources. In particular, I like this one from W3 Schools. Kind of shows you all the different things that you can use with the random module. But this is just sort of a tip to tell you that in Python, whenever you're wondering about how something works or what extra things you can do, Google it. There's so many resources on Python. Because it's the most popular programming language in the world, there's so many things that you can use to learn new bits of Python. So to make sure you got a good grasp on this, let's go ahead and introduce a challenge. And I want you to make your own version of a magic 8-ball that prints yes, no, or maybe each time you ask it. Go ahead, hit pause, do that now. Okay, hopefully that went well. This is sort of a mini project here in its own right, because we're going to have to combine some if statements in printing in order to make this work. So first, we have to have a way to represent yes, no, or maybe in a number form. So I think a good way to do that is with an int. So I'm going to create a variable here called answer, and I'm going to set this equal to random.randint, and I just want the numbers between 1 and 3. So yes will be 1, no will be 2, and maybe will be 3. And then what I'll do is I'll just make 3 if statements. I'll say if answer is equal to 1, colon, then I'm going to print out the word yes. And let's make sure that I spell answer correctly here. There we go. You'll notice with the if statement here, I have to have the 2 equal signs. Remember, when you're comparing things, you have to have the 2 equal signs. And also my print is tabbed over 1 space here. So let's go ahead and fill out the other situations that we'll have. So I'm just going to copy this and paste it. Make sure that you're all the way to the left, that you're not tabbed over. And in this case, I'm going to say if the answer is 2, then I want this to be no. And then finally, make sure I'm at the left, I'll say if the answer is 3, I want this to say maybe. So with this in place, let's run our code. And look, this time it's no, no, maybe, no. Let's see a yes. No, come on. There we go. We finally get a yes. So let's ask it a question. Will I be an expert Python programmer? No. Oh, it's too bad. Let's start working on our fortune cookie project. And let's start with the end in mind. Ultimately, what do we want to have happen? Well, we want to print out a fortune for the user who's wondering what's going to happen to them. So let's go ahead and start with that. Let's make an example fortune that we ultimately want displayed back to the user. So we're going to print out something like, you will have a great day. And we're also going to give the user a lucky number. So let's say lucky, let's make this more personal. Your lucky number is, and then we'll provide a lucky number like 44, okay? And you'll notice every time I reference the term user, I'm just talking about the person who is using your particular project. So if we go ahead and run this, you will have a great day. Your lucky number is 44. That's a good general idea of what we want to have happen, but we don't always want it to be this exact fortune. So let's go through the process of making it so the lucky number changes, and also the beginning fortune that sort of predicts what's going to happen in someone's life changes each time they run this program. So we can do the number fairly easily. First thing that we've got to do is we have to import that random module, okay? Once we've done that, let's go ahead and make a variable that's going to hold our lucky number for our user. So I'm going to say lucky number is equal to, and I'm going to say random.randint to get a random integer. And I'd like this to be between 1 and 100. I think that's kind of a good range for a lucky number for our fortune user. So let's go ahead and now take this lucky number and bring it into our string. Do you remember how to do this? This is your chance to kind of bring it all together. If you'd like a mini challenge, I challenge you, get this lucky number to print. Go ahead, hit pause, do that now. All right, hopefully that went well. What we've got to do is turn this into an F string from a regular string to an F string, which means now we can put variables in it. So instead of 44, I'm going to use my curly brackets and say, please display what's ever inside of lucky number. So now when we run our function, we get our lucky number is 51, 85, 24, 98, 90, 98, 78, 94, 96, 59, 67. Isn't that cool? We just get a different number each time. Okay, so that part is fine, but I don't always want to say you will have a great day. We may want to introduce a little bit of challenge for the potential person. A great family story is my great-grandmother, when she was 85 years old, got a fortune cookie that said she was going to be married that year. So there's all sorts of fun things that we can put into a fortune cookie. So just like we did last time, let's go ahead and create some sort of number that will represent what string we want displayed. Last time we used that for our magic 8 ball to say yes, no, or maybe, but in this case, let's use it to make some different fortunes. So let's make a new variable that we'll just call fortune number, okay? And this is gonna be equal to some different integers. So let's say random.randInt, and let's pick between 1 and 3. This will allow us to have 3 different fortunes. Then we'll have a string to represent the fortune text. So we're gonna say fortune underscore text, and we'll, for the time being, just set it equal to an empty string. Then what we'll do is we'll have our if statements that say, you know, if it's 1 or if it's 2 or if it's 3, and change this fortune text string depending on those situations. So we'll say if fortune number is double equal sign to 1 colon, then we'll want to set our fortune text equal to, and you'll notice how much I've been using the autocomplete. As you build bigger and bigger projects, it comes so handy to have a text editor that can do this. So again, as I started typing fortune, it's asking, you know, do you want the fortune number or text? I can use my up and down arrows on my keyboard to say, I'd like the fortune text, and then I can fill that out. Okay, so we're trying to fill our fortune text with a string. Let's go ahead and set it equal to a nice fortune. So let's say you will have a great day, exclamation point. Awesome. So now we just need to fill out the other 2 potential fortunes. So I'm going to copy the code that we have here, make sure I'm at the very left, hit enter, at the very left, hit enter. So now I need to set a fortune for if the number is 2. And I'm going to introduce a little bit of challenge here. So I'm going to say today will be tough, ... but worth it. Period. So this is kind of saying, you know, might not go exactly as you're hoping for, but you're going to smile at the end of the day. Still kind of a nice positive message there. And then let's go ahead and pay homage to great grandma Carlo. Let's make a fortune that says, you will get married this year. Imagine opening that when you're eating your orange chicken. Okay, so now that we have our fortune text changing depending on what the fortune number is, let's go ahead and update our F string. So where I before had, you will have a great day, I'm going to select all that text and now just start typing some curly brackets, hit my delete, and now I'm just going to put in the name of our variable, fortune text. Let's go ahead and run our code and see what it looks like. Today will be tough, but worth it. Your lucky number is 14. You will have a great day. 26. You will get married this year, and your lucky number is 49. So give yourself a nice pat on the back, and I really hope you enjoyed learning how to bring all these different Python concepts together. We still have 2 more projects in this course, but in order to get to those projects, we've got to learn more Python concepts. Let's keep moving forward. Now that you've finished your first Python project, you've gotten a good idea for the flow of this course. We learn some Python concepts and then bring them all together when we create a project. So it's time for us to learn some new Python concepts in preparation for our next project. So in this video, we're going to be learning about lists. Now this is a new type to us in Python, and all it is it's an ordered list of information. So some examples might be a list of our favorite food, the list showing the results of a race, maybe even just our to-dos that we've got to get done and that they're in a particular order, like this thing is more important than that thing. With lists, the big thing to remember is that they have an order to them. So let's go ahead and create our first example of a list. Let's list out our favorite movies. These are going to be my favorite movies, so feel free to list your own favorite movies. But to create a list in Python is simple. You simply just create an open and close square bracket. This is an example of an empty list. Now to put items inside this list, we simply just type out whatever it is that we want and we separate the items by a comma. So let's say we wanted to have a list of some integers. I can do this by just saying 1, 5, 7, 3. This is a valid list of integers. You can see all the integers are just separated by commas. We can also list out floats. That's completely valid. We can have Boolean values in there, so I could put a true or a false. And we can even have strings inside of our list. Now for our favorite movies, I think the best way to represent them is by their titles, which are going to be strings. So let's go ahead and start with this. So my favorite movie is The Sandlot. I also really like the Lego movie, and I like Dune. So this is a list of my top 3 favorite movies. Now, if you want to see what it looks like when we print this out to the console, we can go ahead and do that. So I'm going to do print fave movies and run this. And you'll notice it's really similar to what it looks like we created on line 1. There's nothing really exciting there. Now, you may be wondering, well, what's the importance of lists? Why do we create these things? What can you do with them? Well, I'll show you one thing that we can do is we can grab individual items from a list. So for example, let's say I wanted to grab the very first item inside of this list called fave movies. How can I do that? Well, first I have to put some square brackets after the name of the list, and then we have to provide which object that are we looking for. So are we looking for the first, the second, or the third? So if I want the very first item, it would seem I'd put the number 1 there. But you'll notice if we go ahead and run this, when I put in the number 1, it gives me back the Lego movie, which is the second item in the list. What's the reason for this? Well, this is because lists use zero-based counting, meaning that in our list, Sandlot is the 0th item. The Lego movie is the first item, and Dune is the second. So it goes 0, 1, 2. So if I wanted to get the Sandlot, I'm going to have to provide the number 0 here. I'm going to give the index of 0. Now if we run this, you can see we do get back the Sandlot. If I want to get Dune, that's going to be 0, 1, 2. So if I put in the number 2, this is going to give back Dune. So this is how you can grab objects from a list. So to make sure you've got a good grasp on lists, I have a challenge for you here. I want you to make a list of your 3 favorite numbers and print the first number from your list. Hit pause, do that now. Okay, hopefully that went well. I'm going to make a new variable here called fave numbers, and I'm going to set this equal to a new empty list. And then I'm going to provide some ints inside of here, and I'm going to print out the very first number. So I'm going to say print my fave numbers, and I'm going to pass it the index of 0. So we should get the number 4 printing. And if we run this, oh, I have fave movies instead of fave numbers listed here. Let's replace that. Let's run. And now we can see that we have the number 4 showing up. Now that we have the basics of lists, let's go and learn a few more tidbits that really makes them powerful in Python. Let's start first by figuring out the length of a list that we create. So here our variable fave movies represents a list of 3 movies that I really like. Now, if I want to find the length or how many items are in that list in Python, I just type out lowercase len, which is short for length, and then I do open and close parentheses. And inside those parentheses, I put in our variable fave movies. Now, in order for us to see what the length is, we have to print it out. So I'm going to do print with an open parentheses and then add one at the end here. So let's go ahead and run this, and you'll see that this list is 3 items long. Now, let's say we want to add something new into the list to take it from 3 to 4. How do we add things into a list? Well, we type out the name of our list, fave movies, and then we do a dot append on it. Okay, so we're going to do append, and then we simply just put inside of the parentheses on append whatever it is that we want to add. So I really like the movie Iron Man, and so I'm going to go ahead and append this onto my list of movies. So if we want to see what the new updated length is, let's copy the line here on 3, put it down on 7, and now when we run, we can see, okay, the list was 3, but after we appended Iron Man, it's now 4. And if you want to see in what location Iron Man was added, let's just simply go ahead and print whatever's inside of fave movies. So I'm going to run this, and you can see, oh, okay, we've got Sandlot, Lego, Dune, just like we started with, and then Iron Man goes on the end. Now, let's say we wanted to add a movie to our list, but we didn't want it to go at the end. Maybe, I want to add the Batman movie, and I want to put it between Sandlot and the Lego movie. It's not my number 1, but it's, not number 3. So how do we put a new item in a specific place? Well, we do that with an insert. So to pull this off, we're going to type out the name of our list again, fave movies, and this time we're going to do a dot insert. And so first, what we have to pass in here is we have to say where we want it to go. So remember, lists use that 0 base counting. So if I want this to go in the number 2 spot, I'm going to go 0, 1. So 1 is the place to put it in the second position. So I'm going to put the number 1 here, comma, and then I'm going to provide the string or whatever object I want to put inside of there. So in this case, this is going to be Batman. So to see what this looks like now, let's print out our list again, and we'll run this. And we can see Batman was put right after Sandlot, but before the Lego movie. So the insert allows us to add something, but add it at a specific place instead of always at the end. Let's say that we've added a movie and we realize, you know what? It really doesn't belong in the list anymore, and I want to get rid of it. Like, let's try and get rid of the Lego movie. Well, what we can do is we can type out the name of our list, fave movies. We have to get to the item that we want to delete. So the Lego movie, if we now look in our console, it's at the 0, 1, 2 index. So I'm going to put the number 2 here. And then I'm going to wrap this all with a DEL, which is short for delete, and parentheses. Okay, so this is going to delete whatever's at the index of 2 inside of fave movies. And again, to see if this works, let's print out fave movies after we've done the deletion. So let's go ahead and run this. And now we can see Sandlot, Batman, Dune, Iron Man, the Lego movie has been wiped out. So to make sure that you've got a good grasp on this, I have a challenge for you. And what I'd like you to do is remove enough items from fave movie until there's only 1 movie left. Okay? Go ahead, hit pause, do that now. Hopefully this went well for you. So I need you to do some deletion a couple of times. The simplest way to do this would just be to say, you know what, I'm going to delete what's ever at the 0 position every single time. And so we could put the number 0 here and do a deletion. If it's down to 4 movies, we have to do it 1, 2, 3 times, and there should only be Iron Man left. So let's go ahead and copy and paste here 3 times, and then let's print out fave movies. Again, it should only have 1 item left. So if we go ahead and run this, you can see we deleted everything down to Iron Man. In this video about for loops, you're going to really understand how cool and powerful programming is. A for loop in Python allows us to execute the same chunk of code over and over and over again. So let's go ahead and create our very first for loop. And we do this by typing out lowercase 4 space, and then we create a variable name, which just for the time being, let's say is number. And then we're going to say in space, and then provide a range, lowercase, and let's put a number in here. I'm going to say 10, and then I'm going to provide a colon. And then on the next line, you can see that it's tabbed over. We're moved over a little bit. I'm going to print out just simply the term hello. So before we dive into what a for loop is and how it works, I think just hitting the run button will really illuminate what's happening here. If we hit run, look what happened. The term hello got printed 10 times. So what we're doing with a for loop is we're saying, okay, let's specify a range of numbers. And when we say range 10, that's saying we want to loop through 10 times. We want to go through 10 numbers, and each time we go through the loop, whatever is indented over, like on line 2, that gets printed out. Now, if we have more than one thing indented, like if we also want to print out hi there, this is also going to get run. So you'll notice if we run this, it says hello and hi there 10 different times. Now you may be wondering, okay, what was the purpose of typing out number on line 1? What does that variable name mean? Well, each time we run the loop, number holds a different value. And to see what it's holding, let's just simply go ahead and print it out. So we're going to print whatever number is each time that we run through. So now when we run this, you can see, look at this. It goes 0, 1, 2, 3, 4, all the way up to 9. So for loops, just like lists, use zero-based counting, meaning that they start with 0 instead of 1. So each time we go through the loop, number first starts as 0, and then it's 1, and then it's 2, 3, 4, 5, 6, all the way down to 9. So it doesn't have to be number. For example, we could replace this with X. This is commonly used in the programming world when you're using loops. So if we run this, you'll notice we get the exact same output. I just think if we're going to be looping through a range of numbers, a good name for this variable is in fact number, and it makes a lot of sense to me. So this is how we create a for loop that's going to loop through a bunch of numbers. Now, what I have at the bottom of this file here is our list that we've created earlier, which has the favorite movies. And something that I really love about lists and for loops is that they can work together to go through each of the items in the list. So for example, let's say I want to print out each of the movies. I can do for movie in fave movies, colon, and then on the print here, I can print out each of the movies, which are held in that variable called movie. They don't have to be called movie. Again, we could name this X, Y, whatever it is that we want. But if we do this and run our code, look at that. It goes through the list and does first Sandlot, then the Lego Movie, and then Dune. And to really just show you how wild these for loops are and how much better computers are than humans at some things, let's make this range really big. Let's say we wanted it to go through 1,000 numbers. It can do that. How long did that take? All of a second? And look, all the numbers are there. Let's say we want to do something just absurdly big. Let's make this 100,000 numbers to loop through. Now, this does take longer than before, but just imagine if you had the task of writing out 100,000 numbers on a piece of paper. I don't think you'd be finishing anytime soon, but you can see here in Python, it's just a couple of seconds to get that finished. So to make sure that you've got a good grasp on for loops, I've got a challenge for you. I want you to loop through 40 times, and each time that you loop, print out the number of the loop times 2. So for example, it should first print out 2, then 4, then 6, then 8, but it should do that 40 times, okay? Go ahead, hit pause, do that now. So hopefully that went well for you. We're going to loop through 40 times. So let's say for number in, and we want to do a range. In this case, we want it to loop through 40 numbers. We'll do a colon, and let's just simply print out first number to make sure we got what we want. For this, we can get rid of the loop that we have up above. We don't need it to be running 100,000 times each time. So let's just go run this. I have to spell print correctly. I had to reload the web page because I had printed too many things there into the console. But now that I have it reloaded, you can see we have the numbers all the way from 0 up to 39 showing. So to do multiplication in Python, we do a number, star sign or asterisk, times 2. And so if we run this, this seems like basically what we want, but remember the zero-based counting sort of throws things off a little bit. So if we really want to make this official so that it goes 2, 4, 6, 8, we'll take this number and we'll add 1 to it. Now, this introduces us to another problem in that in math, when it does this, it's going to do the multiplication first, and then it's going to do the addition. If we want the addition to happen first, we'll have to put parentheses to say number plus 1 happens first, and then multiply that by 2. And now when we do this, you can see that we got 2, 4, 6, 8 all the way up to 80. Now we're going to start learning about dictionaries, which dictionaries are very similar to lists in some ways, but also have some key differences. I like to call them cousins because they're related, but they're not exactly the same. So dictionaries get their name from a dictionary, just like you would think, like the physical book where you look up a word and then it gives you the definition of that word. So with dictionaries, they're called a key value pair, where in the example of the dictionary, the word that you're looking up is the key and then the definition is the value. So let me go ahead and walk through an example, and I think this will start to make sense. So let's say we have a bunch of cats and we want to categorize them based off their age. Well, let's go ahead and create a variable called cats, and to make a dictionary in Python, we're going to do curly brackets. So with lists, we do square brackets. With dictionaries, we do curly brackets. And inside of these curly brackets, we're going to first provide a key, aka the word. This is the word that we're looking up, and then eventually we'll provide the definition or the value. So for the cat, the name of the cat is going to be the key. So in this case, I'm going to have a cat named Jane. And then I'm going to provide a colon, and now I'm going to provide the value, the age of this particular cat. So this cat is 6 years old. So here I have a dictionary called cats with Jane as the key and 6, the cat's age, as the value. So there's only one entry into this dictionary. Let's add a second. So let's say I add another cat named Tom. I'm going to provide a comma to separate the two. That, again, is similar to lists. When you separate items in your list, you have a comma. When you separate entries in your dictionary, you have commas separating them. So I have Tom for the key, and then I'm going to do a colon, and then I'm going to provide Tom's age, which maybe Tom is 14 years old. Let's add one more entry again. Going to do a comma. I have to provide the name of another cat. So let's just go ahead and do Sarah, and Sarah is going to be 8 years old. So here we have a dictionary with 3 entries, and we have strings as the keys and ints as the values. So if we just want to see what this looks like, let's go ahead and print this in the console. So I'm going to say print cats. It looks really similar to how we set things up. But let's say we want to go grab a specific item from the dictionary. Well, like lists, we go ahead and we put square brackets at the end of this, but we just put the key that we're looking for. So for example, if I want to see how old Tom the cat is, I type capital Tom and hit run, and I get back the number 14 because it looks up the word or the key Tom and gives me back the value or definition of 14. And it's really important that I spell Tom with all the correct spelling. If I have lowercase Tom here, you'll notice I get an error here that says, hey, I can't find this in the dictionary. It has to be the exact spelling. So let's try this out with Jane. If I want to get Jane's age, you'll see I get the number 6. And this is a one-way street. We can only provide the keys here. For example, if I say, find me the cat with the age of 8, so I put 8 inside of the square brackets, I'm going to get an error. I can only provide keys here. So some additional things that we can do with dictionaries. Let's say that we want to add something new to the dictionary. I can just say the name of the dictionary, cats, and provide a new key. Like let's introduce a new cat named Wilson. And let's say that Wilson is very young, just 1 year old. If we now print out the dictionary of cats, you'll see Wilson has been added to the dictionary. If we wanted to delete something from the dictionary, we can say del, just like we did before with lists, and provide the name cats, square brackets, and let's say we want to get Tom out of the dictionary. If we go ahead and run this now, you can see Tom has been deleted. So you know how to add, you know how to delete. Same thing with list 2. If you want to find the length of a dictionary, you can go ahead and do that as well. Let's put this inside of our print statement here. Okay, this will give us the lengths of the cats dictionary, and there you can see it. So to make sure you got a good grasp on dictionaries, my challenge for you is create a dictionary with ints for keys and Booleans for values. You can feel free to name it whatever it is that you'd like. Go ahead, hit pause, do that now. Okay, hopefully that went well. So I'm going to create a new dictionary here. I'm going to just call this simply what it is. I'm going to call it Ints and Bools. And I'm going to say that this is a dictionary because I've got my curly brackets. So I'm going to provide an int, like let's just say the number 5 for the key, and I'm going to say colon, and then provide either true or false. So I've got true here. Let's do the number 7, which in this case we'll say is false, and then we'll do like 144, and this is also false. So here you can see I have a dictionary with integers as the keys and Booleans as the values. And one last tidbit, you'll notice sometimes, whether it be lists or dictionaries, you can have spaces in between the items in there, or you can have them right next to each other. Personally, I like to have one space after each just so that it's a little bit easier to read, but both are completely valid Python code. Congratulations, you've learned enough Python to bring on yet another project. This project is going to be the word counter. The idea is that we can take a really large piece of text, maybe a speech, a song, a whole book even, and we can say this is how many words there are in this piece of text, and this is how often this word appears, or this word, or this word. So, before we move forward, there's one last concept that we've got to learn, and that's how do we take text and then put it into a list so that we can actually loop through and do some analysis on it. So the first thing that we want to do is we want to get a really large piece of text. And so for this, I'm going to use the Gettysburg Address, a famous speech by Abraham Lincoln. My grandma growing up always told me she'd give me $20 if I memorized it. I never did, but I will never forget what the Gettysburg Address is because of that. So feel free to use song lyrics or whatever big piece of text that you'd like, but copy some big piece of text and let's come put it into our project. So I'm going to make a variable called text, and I'm going to set it equal to, and I'll do my double quotes and hit enter, but you'll notice we have a really big problem. That's that this text goes to multiple lines here. So I could go through and say, I'm going to delete this back until we get here, and I'll delete this, and I can go, and this is technically all one line, but something that we can do that's even better than this is we can make a string with triple quotes. And what triple quotes does is it allows you to use multi-lines and have it be all one string. So for example, if I just do 3 double quotes here, and then I put my cursor in the middle and break them apart, in the middle I can put this whole Gettysburg Address, and this is just one big string. If you're using song lyrics, this will be really helpful because there's just tons and tons of new lines that you would have to deal with. So just to make sure this is working, let's go ahead and print out the text here. Make sure that our triple quote is all that we thought it was. We'll hit run, and we can see the Gettysburg Address is printing. Now, here's that situation. If we're going to do any sort of analysis to see how many words there are and do some counting, we have to break these out into individual words. For example, if we wanted to find the length of how many words there are, if we simply did a len around the text, this would tell us how many characters there are, but it would not tell us how many words there are. So for example, this is saying that there's 1,477 characters, but that's not the amount of words. The words is what we're interested in. So what we can do with our text is we can say text dot and then split with open and close parentheses. And what this does is it takes this string, and anywhere that there's a space is it breaks it off into strings inside of a list. So if we print out what this gives us, you'll notice, I'm going to scroll to the top here, there's an opening square bracket, and then we have an ending square bracket, and we now have a list of a bunch of strings. So what we could do now is say, okay, I want to know the length of this list of words. So if we go ahead and run this, now we can see that we have 278 words. So this is probably a good place for us to stop. We've learned how to take really big strings and represent them in triple quotes, and we also know how to count the individual words. The next step for us is to be able to count how often a particular word appears. Currently, our word counter can tell us how many words there are in a particular piece of text, but it doesn't tell us how many times a particular word appears. So for us working on this next part of our code, I think it will help if we really simplify the text that we're looking at. So just temporarily, I'm going to get rid of the speech and just bring in some letters. So I'm going to have A, B, C, A, and then also B, so that we have a few letters that are repeating. So just to make sure this is working, let's go ahead and run this. It says that we have 6 words. And if we get rid of the length here to say, just show me what we have, we can see, okay, I've got a list of A, B, C, A, B. So now, if we want to count these, the question is, how do we do that? Well, a great way to go about this is to use a dictionary, because with a dictionary, we could store the words, or in this case, these letters, as the keys, and then the count of how many times they appear as an integer. So for this, let's go ahead and create a variable that will hold our dictionary. We'll call it word_count. And we're going to set this equal to an empty dictionary. And we do that with the curly brackets. Next, because text.split gives us back a list, we are going to use a for loop to go through that list. See how we're bringing everything together? We're going to say for word in, and then we want to have our text.split like this, and then we'll do our colon, and just to make sure that this is working, let's go ahead and print out whatever the particular word is. So let's run our code, and we can see A, B, C, A, B. Awesome. So we're able to loop through the list and look at each individual word. Now what we're going to do is we'd like to assign each of the words that we come through as a key in the dictionary and then provide 1 as its value to say this has shown up once. So what we'll do is we'll say word count, which is our dictionary here, and we're going to say we want to pass in as a key whatever the particular word is that we're working through right now. So it might be A, B, C, A again, and we're going to say that the value should be equal to 1. So let's go ahead and do that, and then on the very left here, let's print out whatever word count is. We want to see what's now inside of that. So if we run our code, we can see, okay, we get a dictionary and it covers all the letters, A, B, C, but it just shows that they show up 1 time. How can we make it so that it does a little comparison to say, hey, if it's already exists in the dictionary, then we want to increase that number? Well, what we can do is we can use an if statement to check and see if a word is inside of our dictionary already. So we can say if word in, and we'll say word count, which is our dictionary. We're saying, does this word exist in the word count dictionary? If it already is there, we're going to take word count, provide the word that we're currently looking at that we know is already inside of the dictionary, and we want to add 1 to whatever the count is. So what we could do is we could say word count at word is equal to word count at word plus 1. But there's a simpler way to do this in Python. We can simply just say, take whatever the word count at word is, and then do a plus equals 1. It just says, whatever the existing number is, add 1 to it. If we look at this if statement here, this is saying if the word is in the dictionary. If the word is not in the dictionary, that's our else situation. And make sure that this is on the same tab spacing over here as the if. We want to simply just add that word to the dictionary and give it the value of 1. So let's go ahead and run this, and look what we get. We get a dictionary that says A shows up 3 times, B shows up 2, and C only once. So if we kind of work through this example, when we loop through this list, we're going to say, okay, A is the first word. Is A inside of word count? It is not. So we'll put A in the dictionary and set it equal to 1. Then we do that for B and C. So at that point, we would have a dictionary with A, B, and C all being 1. But when A comes along, it's going to say, oh, A is already inside the dictionary. So A currently has a value of 1, add 1 to it. So 1 becomes 2. And when we do A again, then it becomes 3. And when we do B, it goes from 1 to 2. You see how we're combining both a for loop with a list to our dictionary to do this counting? It's really fun how these things all connect here. Now, one last piece that I'd like to show you is, let's say I had an uppercase letter like A, and I go ahead and run this. You'll notice this adds a whole new entry in the dictionary, when in reality, I don't really care too much about what the uppercase or lowercase situation is. I want to count all the words. So a way that we can fix this is on our particular piece of text here, we can say dot lower, and this will make all the text inside of that string lowercase. So by making this change here, and it's not here that we'll have to change it. In fact, it's down here inside of the for loop. Okay, so we've got dot lower and then a dot split on that. If we run this, you can see this now doesn't look at whether it's capitalized or not. It just does all the proper counting. So let's go ahead and grab the text from the Gettysburg Address. I'm going to copy this and paste it inside of our triple quotes. And now when we run our code, we can see that we get some great counting. So I can see that the word have shows up 5 times. The word we shows up 10, 2, 8 times. And you can go through and scour all the different counts of the word there. Congratulations on finishing project number 2. I hope you're feeling the excitement of Python. Congrats! You've now finished your second Python project, and we're back to learning concepts. We've got one last project that we're going to finish up to wrap up the whole course. So let's learn the skills that we need in order to do that. So in this video, we're going to be learning about functions, which functions are a way to give a name to a chunk of code. It's about that simple. So how do you make a function in Python? Well, first you type out the word def. Def is short for define. Whenever you make a function, create a function, it's also called defining a function. So that's why we have the term def here. So we say def space, and then we give our function a name. So I want a function that can print out a dog barking. So I'm going to call my function bark, and then I'm going to give some open and close parentheses, and then I'm going to wrap it up with a colon. So you've noticed anytime in Python that we see the colon at the end of something, typically when we hit enter to the next line, we're tabbed over because that's saying, we want to do something if something above has happened. You've seen this like with the if statement. It's sort of everything that's tabbed over belongs to the thing above it that is not indented and tabbed over. So for example, with this bark function, if I want to make some dog noises, so I'm going to print here, and I'm going to say woof, woof. That was a horrible dog impression. Woof, woof. There we go. That's a little better. This is now a function called bark that's going to print out the words woof, woof. So if we want to go and test it, we'll hit the run button here, and you'll notice nothing shows up. And you're saying, that's weird. We have a print that says woof, woof. It should be showing up on the console. What's going on here? Well, with functions, like I said, it only gives a name to some code. So for example, we've just said whatever's on line 2 now has the name bark connected with it. If we want that code to actually run, we have to type out the name of the function. This is called calling the function. So on line 4, I can say here, bark, and I include those open and close parentheses. And now if I run this, I get the woof woof to show up. And what's so cool is I can call bark, 2, 3 times, no matter how many times I want to. Each time that I call the function, it's going to run the code connected in there. And what's cool about function is they don't have to just be one line of code. So for example, I can also print out here and say something like, I'm a dog. And when I run this, both of those lines get printed because they're both indented over. They're both part of that bark function. Kind of see how this is connected here? So a really fun thing to connect this with is a for loop. So I'm going to just say for x in a range of, and let's do this like 100 times. This is going to loop through 100 times, and each time I want to run the bark function. And just doing this, now if I run this, that shows up 100 times over here on the console. Isn't that great? So as your Python projects get more and more complex, these functions are very helpful to be able to organize code and say, okay, I want to give a general name to this chunk of code so that I can run it over and over again in multiple places in my project. So to make sure that you've got a good grasp on this, I have a challenge for you. I want you to create a function called hello that prints hello Nick. Hit pause, do that now. All right, hopefully that went well. So I'm going to create a function that's going to be called hello, and we're just going to do the colon here, and I want this to print out the statement, hello Nick. And I'll go ahead and copy and paste that, run it, and you'll notice nothing shows up. That's because we haven't called it. So to make sure it really works here, let's call the function and now we get that hello Nick. Let's continue our discussion of functions by talking about parameters. Parameters are a way for us to pass some information into a function. And why would this be useful? Well, let's take a look at our challenge that we had from the last video where we print out hello Nick. Every time we run this, it says hello Nick in the console. Okay, what if we wanted to make a function where each time we run it, we could pass in a new person's name and have that be printed? Well, we can with parameters. So parameters go inside of these parentheses here. If you're wondering what those are about, now you're about to learn. So with a function, you create a name of a variable that's going to be passed into your function. So in this case, if we want to print out someone's name, I'm just going to put name for the name of that. So we have this function called hello that takes in a parameter name. And the way that we can use this is I'm going to turn this string into an F string, and where we have Nick, I'm going to replace this with whatever the variable name holds. We'll get rid of that extra curly bracket there. And you'll notice now if I go and try and run this code here, I get an error because it's saying, hey, on line 4, you're trying to call this function hello, but you're not passing in the name parameter. So if I change this and pass in, for example, Nick, and run this, well, now what happens is it says hello Nick. But what's so cool is I can say hello Nick, hello Sarah, I can say hello John. There's so many different things that I can pass into this function in order to get it to work. So let's say that you want to have more than one parameter being passed into a function. Well, we could make a new function here that we could call add numbers. And this is going to take in 2 numbers. So I'm going to call this maybe num1 and num2. Okay, again, the name of these can be whatever you want, but I think that's pretty descriptive. So what's going to happen here is I'm going to print out whatever num1 plus num2 is. Okay, I'm going to add some spaces to make it a little bit more readable, but let's go ahead and call this. So I'm going to say I want to call add numbers, and I'm going to pass in some numbers like, let's see what 4 plus 8 is. So I'm going to go ahead and run this code, and look, I get the number 12. So what's happening here on line 9 is we give the numbers 4 and 8 into the function, which means that when we're actually running the code, it says, okay, num1 is equal to 4, num2 is equal to 8, and then it does the addition for us on line 7. And again, we can call this as many times as we'd like to. So I can say add numbers, let's see what 3 plus 7 is equal to, and apparently it's 10. So with this, I have a challenge for you to make sure you've got a good grasp on parameters. What I'd like you to do is create a function called dog_info that takes in a dog's age and name and prints out a sentence about the dog. Hit pause, do that now. Okay, hopefully that went well. So what I'm going to do here is make a new function called dog_info, and this dog_info is going to take in an age and also a name. I'm going to do a colon here, and I'm going to print out a sentence about this dog, something like, hi, my name is Fido, and I am 8 years old. We're going to replace Fido. First, we have to make this an F string, and then we're going to replace Fido with the name, and we're going to replace 8 with the age. So let's go ahead and test and make sure that this is official. I'm going to say dog_info, and we're going to pass in some parameters here. First, I'm going to pass in the age, which will be something like 4, and then also the name, which let's do Sarah this time. So let's run our code, and look, we get, hi, my name is Sarah, and I am 4 years old. Now, this is going to be our last video talking about functions, and it's because I have one last concept to teach you, and that's about returning information. So with functions, we can pass in information via parameters, but we can also pass out information with returning that information. So let's go ahead and create an example where we have a function that's going to double a number. So I'm going to say def double. So we're defining a function called double. Inside of the parentheses, our parameter is going to be a number. We want someone to pass in a number, and we want to multiply that number by 2. So here inside of the function, I'm going to say number times 2. Then I'm going to call this function and say, I want to double the number 5. And when I run this, you'll see we get nothing. Okay, well, this is kind of expected. We never printed anything anywhere. So what we could do is we could print here inside of the function, say, okay, print whatever number times 2 is, and that's fine. That works. But what we could also do is instead of printing, we can take whatever number times 2 is and return that. So we just type return, all lowercase, space, and then give whatever it is that we want to spit back. We can give back integers, strings, booleans, floats, doesn't matter. So now doing this, if we go ahead and run, you'll notice we still don't have an output, but whenever we call this function like we do on line 4, this now becomes an integer that we can actually work with. So for example, if I print double and pass in the number 5 there and run this, I'll get the number 10 printed. And to really sort of drive this home, let's say I create a new variable here. I'm going to call it new number, and it's equal to calling the function double and passing in 5. I can take whatever that function is, in this case the number times 2, and use it as an integer. So that now if I print, I want to see what's inside of new number, you'll notice it gives us back the number 10. It's taking the number 5, multiplying it by 2, and then pushing that back in here. The reason it's doing that is because it's returning, it's coming back out of the function and now being able to be used. So with this in place, I have a challenge for you. And so what I'd like you to do is I'd like you to make a function that returns a string in all caps. Now, I have not taught you this. I have shown you how to lowercase things, so you might be able to just guess what it is to uppercase. But I also thought this would be a good chance for you to exercise learning how to go out and grab information on your own. Okay, hit pause, do that now. Okay, hopefully that went well for you. I hope you enjoyed the twist that I had. So I'm going to make a function here, and I'm going to call this uppercase. And what we're going to take in here is some text. And what we want to do with this text is we want to return that text, but then make it uppercase. So we're going to do a dot upper on this, okay? So we have this. Let's go ahead and test it out. I'm going to print, and I want a lowercase nick, and then I'm going to pass that into my uppercase. So I'm going to say uppercase, do an open parentheses, and now an ending one. Let's see what this looks like. So I'll run this, and we get all caps Nick. So a really cool thing that we can do now with functions is, look at this. This is going to be so much fun here. So let's go ahead and make a list of names. So I'm going to say name is equal to, and let's just add some names. I've got Nick. Let's do Jane, and we'll also provide Sarah. Okay. So here I've just got a list of 3 names. What I can do is make a for loop that says for name in names, colon, and then what I can do is use this printing of the uppercase. So I'm going to copy and paste that here, and I can pass in the name as we go through each time. Oh, I need to update this list to be names with an S. So look at this. It's going to take all of these and uppercase them and print them. So we run this, look, Nick, Jane, Sarah. Oh, isn't this cool to see the functionality we're getting with the functions applied with the for loops? You can see how we're really gaining some skills here. In this video, we're going to be learning about comments. They're a way to be able to leave notes or ideas to ourselves in our code and not run them as code. So to give a clear example of how this works, let's first say that, we're going through an example where we have a wallet that's equal to $40. And with our wallet, we decided that we were going to go buy some food, and maybe it cost $8. So we've covered this earlier, but if we wanted our wallet to lose $8, we could say the wallet is equal to wallet minus 8, or we could do this fancy thing where we say wallet minus equals 8. That's just saying take $8 away. But then let's say, it's payday and all of a sudden our wallet got an extra $40. So we can say plus equals 40. So if we had written this code and, we knew this story about how we had the initial money, then spent it on food, and then got a payday, that's all great. But let's say I wrote this code and then came back later and I'm thinking, wallet's 40 and then it loses 8 and it gains 40. Why? What are the reasons behind this? What we can do is we can add comments to our code to show what it is that we were thinking when we were writing the code. So for example, where I have wallet minus equals 8, after that, if I do the pound sign or the hashtag sign, you can say anything that you want after that and it will not get run as code. So for example, I could say, I bought some food. And you'll notice this doesn't affect the output. We don't get any errors. If I tried to write, for example, I bought food on another line of code and run it, we're going to get a big error because it's saying, what is this, a variable you're trying to reference? Like, what is this? So the comments, anything after the pound sign, that's going to allow us to sort of leave a note to ourselves. Again, I could say here, I got a payday. Woohoo, something like that. And you'll see with these comments, it makes so much more sense. The other cool things we can do with comments is we can say, okay, maybe I'm working on some code where I'm trying to remember how is it that we make, text uppercase. So I have the term Nick here and I'm thinking, is it .up? And I go and I try and run this and it's like, oh, this is not exactly what it was. What you can do is you can add a comment in the front of this to say, I want to eventually get this code to work. I'm just not exactly sure how to do it. So I could comment out this line and maybe add a line above it with a comment that says, I need to figure out how to uppercase this. And so that later you can come back and say, oh, okay, I figured out how to do this. What you do is you actually have to say upper. And so you put in the correct thing and you simply just uncomment your code and you're back to where you were. And so the comment can be used as a nice way to sort of put things away for a second to say, I can't exactly get this to work right now, but I do want to use this later. So an interesting thing is every time I've given you a challenge, you'll notice that I've been doing it with a comment, right? I've had a little pound sign and then I've had my comment down below. So finally, this starts to make sense. And this is sort of a meta challenge here, but I want you to create a comment like the one that we have. Hit pause, do that now. So you could have created anything that you wanted. I'll make one that maybe you're thinking, I know how to do this now, Nick, something like that. But hopefully this was a great light bulb moment to say, oh, we've seen this over and over again, but now I understand. A similar light bulb moment might be, remember how we learned about parameters and functions and how they work? You notice every time we do a print, this is us just calling the print function. And what do we pass in there? We pass in a parameter of what we want printed, like hello here. So this print should make a whole lot more sense. Now, we didn't create the print function. That's all part of Python and its library of code. But whenever we print, we are calling the print function and passing in a parameter. Isn't that cool how you're starting to make these connections? I'm going to be honest. This might be the funnest video of the whole course. We're going to be learning about input. And what's so cool about input is it allows users who are running Python code to actually interact and make decisions with that code. So let's go ahead and create our very first input, just all lowercase, type out input, and then do some parentheses. And inside of the parentheses, we need to provide a string. And this is going to be the prompt that's going to be shown in the console. So for example, just type here, enter some text. Okay, and you'll see how this works. So if we run this, you'll notice on the console, we now have the ability to type in some information. Isn't that cool? And we can hit enter. And what's so great is we can take whatever it is that someone types in and put it into a variable. So I can say, for example, user text is equal to whatever this input is, and then I can print this out. So I can say, I want to print the user text. So let's go ahead and run this. And I'll say something like hello, and I'll hit enter. And look, we get hello shown below. And what's so awesome is, for example, we can take this user text and uppercase it. So I can say upper here. And so now when someone enters in some text, it'll get uppercased. So I'm going to say again, my hello. And when I hit enter, it makes it all caps. Isn't that great? Now, one thing I want to show here, this is just a usability thing, is that when someone runs this, it's really kind of awkward. It says, oh, enter some text, and they start typing, and it's immediately right next to the word text. Like, it kind of makes it hard to look at. So something that we can do is I like to provide a colon at the end of this and a space, so that when someone runs this, it says enter some text, and now when I say like Nick, for instance, there's a little bit of separation. They understand that, okay, after the colon, this is the text that I'm entering in, and they can hit enter. And boom, they get Nick blown up like that. So the one thing that I want to emphasize here is that when we get input from the console, it always comes through as a string. So for example, let's say I want to take whatever someone has inputted and I want to double it. So let's say I have an input here, and I'm going to say that the prompt here is something like, what do you want to double? And I'll do a space there. And we're going to put this into a variable that I'll call user number. And then what I'm going to do with this user number is I'm going to print out whatever that number is times 2. So I'm going to say user number times 2. So if I go ahead and run this, oh, we got to do the above thing. So what do you want to double? I want to double the number 8. So I put in the number 8, and look, it just takes the number 8, which is a string, right? Because the thing that we get back from the input is a string, and it doubles it in that it just repeats the string 2 times. So if you want this user number to be treated as an int, we have to say lowercase int, open parentheses, and wrap that string so that it turns into an int. So now if we run this again, and I put in the number 8, you'll see we get the appropriate 16. So this is where you have to be careful with the type, that we're always getting back a string. So if you want it to be something else like a double or an int, you've got to do some work to convert it. So to make sure that you've got a good grasp on this, I have a challenge for you. First, I want you to ask the user for some text, and then ask them whether they want it uppercased or lowercased. I have some example text here that might help you. So you can use what we already have up above, but basically just enhance it so that it doesn't always uppercase it. It lets the user decide whether they want to uppercase it or lowercase it. Hit pause, do that now. All right, hopefully that went well. So because we know how to comment things, I'm going to take the text that we have here, I'm going to comment this out and put it down below so that we don't have to worry about this, okay? And then I'm going to go to work here. So we do have the enter some text, that's great, but then we also need to decide, do they want to uppercase or lowercase it? So I'm going to copy this here, I'm going to do another input and paste that in there. The variable that we should call this, let's go ahead and call it something like upper or lower. And we're going to set this equal to that. So the user should be typing in 1 or 2. So what we want to do is use an if statement to say, okay, if the input, this upper or lower, is equal to, and again, remember, this is a string. So if it's equal to the number 1, like this, then we'll want to print the text to be uppercase. So we're going to reuse our code here that takes that and uppercases it. And in the else situation, which means they probably entered in the number 2. They technically could have entered in anything, and this will still run. But we want to take the text, instead of uppercasing it, we are going to lowercase it. So we're going to say lower here. All right, so let's clean this up a little bit, run this. So first enter some text. I'm going to say capital Nick, and it says, do you want to uppercase it? So if I say 1, look, it does the all caps Nick. Let's do the same situation where I have Nick, but I say, oh, no, I want to lowercase it. Look, it does the lowercase. I told you, this would be one of the most fun videos. Well, congratulations. You've made it to the final project of the course. We've learned so much Python, and it's going to be awesome to wrap it all together here in this final project. So we'll be creating a number guessing game. The idea is that our Python code will pick a random number between 1 and 100, and then the user will try and guess it. And each time that they guess, we'll tell them either, hey, you got to guess higher next time, or you got to get lower. They'll give them some clue about where to guess next time. And eventually, once they get it right, we'll say, hey, you got the right answer, which was 42, and it took you 7 tries to get there. That way, they have this little score to say, okay, next time I'm going to try and get it down to 6 or 5 or 4, whatever. So in order for us to create this project, we have an interesting situation. So let's just start building this, and you're going to see where this comes up. So we need to get some input from the user as to what their guess is. So we're going to create a variable here called guess, and this is going to be equal to an input. Remember, we learned input's the way to get back information from a user. So we're going to say, what is your guess? Question mark, and let's do the colon space, which just kind of makes it look nice. Remember, we want this guess to be a number, not a string as the default type that's going to come back here. So we want to convert this input into an int. Then we're also going to have the correct number. So for right now, let's just go ahead and set it equal to something we know, like the number 5. And then you might say, okay, well, we need to, ask the same question, what is your guess, over and over until they get it correct. So it would be really nice to use a for loop here. But the problem with for loops is you have to know how many times you're going to loop through. It could be 4 times, could be 20. They might get it right the very first time. We really don't know. So we can't actually use a for loop, but we can use a new concept called a while loop. And a while loop is basically a combination of an if statement and a for loop brought together. It's a great tool for when you find yourself in a situation of saying, I want to loop through something, but I don't know how many times I want to loop. I want to loop until some situation is true. So with the while loop here, we're going to say while, and we're going to say that guess is not equal to the correct number. Okay, and then we'll do our colon here. So this reads a lot like an if statement. Again, this guess not equal to correct number, that ultimately turns into a Boolean. And basically, this while loop is going to run over and over until that condition is equal to true. So while the guess is not equal to the correct number, it's going to keep looping through. But once that guess is equal to the correct number, then it will stop looping and we can run some code below it. So while we're inside of this while loop, we want to keep updating what the guess is. So we're going to keep asking, hey, what's your guess? What's your guess? And then eventually, once they get it correct, we want to print out and say, hey, you got the right answer. So let's go ahead and just do a little print statement here. You got the right answer. We'll even add a little smiley face. Okay, so let's go ahead and run this. We're going to ask, what's your guess? I'll put 1, 2. I'll try some bigger numbers here. And you can see, well, I got an error here because one time I didn't put in a valid number. Let's try running this again. Okay, I keep putting in numbers here. And look, this will just keep going on forever and ever and ever until I put in the correct answer, which, look, I'm going to put in the number 5. And we get the message, you got the right answer. So this is the really magical part of the while loop, is it only runs as many times as you need to until that condition is equal to true. So let's run this one more time, and I'm going to put in the correct guess off the get-go. And look at that. Instantly, it says you got the right answer. It doesn't have to do it an extra loop. No, it just, as soon as that thing is true, it gets out of the while loop and starts running the other lines of code that you have. So one more thing that we'd like to add to our project here, we're going to add some details in the next video, but we also need to be able to count how many times they've guessed. So I'm going to create a variable called guess count, and we'll start this at 0. And each time we go through the while loop, we're going to say that the guess count needs to increase by 1. So we're going to do that fancy plus equals 1. And then eventually when we print, let's use an F string here. Let's really tell them what the right answer is. So we're going to say the right answer was, and let's put inside that correct number. Okay. Let's add a little message of congrats. So we'll say, congrats, the right answer was, for example, 42 or whatever it is. And then we'll say, it took you 43 guesses. Didn't really take that many, but what we'll do is we'll replace the number 43 with whatever guess count is. Okay, so let's go ahead and run this, and let's try some guesses which are incorrect here. Okay, and we've tried all these times, but let's put in the correct guess, and it says, hey, the answer was 5 and it took you 7 guesses. Let's try again. So let's go ahead and just do a couple this time. Let's say the third time, look at that. Congrats, the right answer was 5 and it took you 2 guesses. Now, look at this. It actually took us 3 guesses, so we're doing our counting incorrect here. So we need to make sure that this guess count starts at the number 1, not at 0. So let's try this again. We'll do 2 wrong answers, then the right. And now it correctly says, congrats, the right answer was 5. It took you 3 guesses. So we have a nice solid foundation for our project here. Essentially, the game is working, but there's a lot that we'd like to add here. We want to say, whether they need to guess higher or lower. We also need to pick a random number so the answer is not always 5. Let's talk about that in the next video. We're going to keep improving our number guessing game here, and we're going to start with the feature where we can tell the user they either need to guess higher or lower. So what we can do is inside of this while loop, each time we're asking for a new guess, we can use an if statement to check and see whether their guess was too high or too low. So we can say if guess is less than the correct number, In that case, they guessed too low, so we need to tell them to guess higher. So we still want to do this line here that says that we want, the guess to be the result of an input and convert it into an int, but we want a message a little bit before guess that says, maybe we'll say wrong, period, you need to guess higher, because their guess was less than the correct number. So the else part of this, and make sure this is tabbed on the same line as the if, we need to make sure that these two line up. We're going to also update the guess variable, but we're simply just going to change part of this to say that you need to guess lower instead of higher. So let's go ahead and give this a shot and make sure that it's working. So let's guess something below, like 1. It says you need to guess higher. Let's try 2, 4. Yep, it's still saying higher. Let's try 6. Look at that. You need to guess lower. Okay, so now the person using the game has an idea of whether they need to go higher or lower. The next bit is that the answer is always the number 5. We need to fix this. So because we're going to be using randomness, we need to make sure that we import random here so that we can use this library of code. And so I'm going to say, instead of the correct number always being 5, I'm going to say random.rand int, and I want it to be between 1 and 100. And you'll notice this nice helpful text here. It tells us this includes both endpoints. So we're secure in knowing that, okay, it's going to have 1 and 100. Now, this is also a good point to say we should probably print and tell the user that the number is going to be between 1 and 100 so that they know what range they should be guessing in. So let's go ahead and put a little intro here, and we'll say, hi, welcome to the guessing game. Please guess a number between 1 and 100. Okay, so let's go ahead and run this, see what it looks like. Hi, welcome to the guessing game. Please guess a number between 1 and 100. What is your guess? So I don't know what the guess is. So this is going to be the first time we're actually playing our game for real. So let's try the number 50. Okay, it says we need to go lower. Let's try 25. Look at that. 25 was the right answer. We didn't even have to go too far. Okay, you can see it worked. We got 2 guesses. Let's try this again. Go with the number 50. We need to go lower. Let's try 25. Need to go lower than that. 13. Okay, it's between 13 and 25. So 20, 17, 18. Look at that. The right answer was 18, and it took us 6 guesses. Wow, isn't this fun? We got the basic guts of the game working, and really the last bit that I'd like to show here to really put some polish on our game is that I think it would be fun for someone using this game to make it seem like the program is alive and there's actually some life to it. So what we can do is we can introduce some pauses in between when things are shown on the screen to add a little bit of dramatic effect. So I'm going to import a new library here called time. And what we're going to do with time is just sort of put some pauses between things. So we're going to update this message. Hi, welcome to the guessing game. And I'm going to change this to say, I am going to pick a number between 1 and 100. And then I'm going to print out on a separate line here and say, picking a number, ... And then now it'll ask, what is your guess? So if we just run this right now as is, you'll see, hi, welcome to the game. I'm going to pick a number between 1 and 100. Picking a number, what is your guess? Just, there's no magic there. But what we can do with this time now is I can say, okay, I want to say time.sleep, and you just put in the number of seconds that you want things to pause. So maybe I'll put 3 seconds here. And then after picking a number, I'm going to put 2 seconds. So I'm going to say time.sleep and add 2 seconds here. And I want you to notice the feel of this now. So if we stop and run this again, hi, welcome to the guessing game. I'm going to pick a number between 1 and 100. Picking a number. What is your guess? Do you see how now there's just a little bit of life here? And so I'll go ahead and make my guess, and it says 50, and it can say wrong. You need to guess lower. You can decide if you want to have a sleep inside of here. So you could say, let's at least give 1 second to give back an answer. Like we could say, let's do a sleep for like 1. Let's see how this feels. So we'll stop and run this again. Hi, welcome to the guessing game. Pick a number between 1 and 100. Picking a number. What's your guess? 50. Wrong. You need to guess higher. What's your guess? 75. Wrong. And so, at least to me, even though technically we do not need these time sleeps at all, in fact, it's making our program here slower, I think this really brings a little bit of magic to the situation in that someone is actually thinking, hey, I think this code is thinking and making this guess, even though, it doesn't really have a soul. This brings some life to the project, in my opinion. So there you have it. You've created your last and final project of the course. You should feel very proud of yourself. Let's go ahead and wrap things up with where you can go next with your new Python skills.